Thank you very much. This is the most important session for today. Finally, we have a father of the Japan Internet, Jun Murai here. It's very difficult to get him to be Taiwan. I get Suguru Yamaguchi in Taiwan, but not Jun. This is the very first time for me. Okay. I think many of you know the Jun Murai for years, but let me try a little bit, introduction for him. Jun Murai, of course, she received a PhD in computer science at Keio University in 1987. And of course, he established the Japan University Unix network, and the first network in the Japan connecting with multiple university in 1984. In 1988, he established the Y projects, and the Y project actually is still running, and the project is a Japanese Internet Research Consortium. Even today they're still running it, and I think Hisaki is a chair now.
Yeah.
Okay, and then so he's a special advisor for the cabinet in Japan, particularly the Japan government, and also the advice to the digital agency. Chair and serve for the many government committee and active in the many international science association. He was a member of the IAB. If you know, the IAB is an Internet Architecture Board in the 1993 to 1995. He is a board of the trustee of the Internet Society 1997 to year 2000. And the board of the director of the ICANN. I think you are the first board member, right? Yeah. Because it's 1998 to year 2000. He is also be well known to be appointed in the Internet Hall of Fame. I think only 2 or 3 from Japan, you and Kim Nam, Takahashi.
From Korea, Takahashi-san.
Oh, Kim Nam is from Korea. Is not Japan. I thought he's Japanese.
No, he's Korean.
It's okay. Yeah. Okay. So anyway, today is an honor to introduce Jun Murai to talking about digital civilization in Asia. Please.
Okay, thank you very much, Go-sensei. Okay, thank you very much for inviting me, and it's an honor to come back to Taiwan, and in various ways. Let me talk about my title is a digital civilization in Asia Pacific, but I use civilization for the internet development these days. Actually, the next month, I'm going to be publishing my maybe last book in Japan called The Internet Civilization. That's the title of my new book. Well, unfortunately in the Japanese language. But anyway, so let me talk this way. As I introduced, I've been serving for the internet development from the very day one, day zero maybe. Working on a Unix operating system and packet switching, but mainly the internet started from the Unix operating system side, and then the ARPANET, the packet switching network side, and then it's merging together. But I came from a Unix operating system side, so I'm basically the operating system person. But anyway, so from that point of view, let me see. Okay, so from that point of view, then probably viewing the today's condition of on the internet, then it's a very important that 3 elements, category is going to be important. The internet, of course, is a really important one. So probably from the IGF point of view, Internet Governance Forum, probably IGF is not discussing about the internet only anymore. So it's always talking about the digital society, digital infrastructure, digital services, AI maybe. It's going to be a very important topic, which is the digital data exchanged and accessed over the internet, and then the computation is going to be changing a lot of space of artificial intelligence because of the scale and the the quality, and that's maybe especially the past 2 years, then the situation has been changed, and so it's a kind of three categories heated up and growing very rapidly. So that's an infrastructure of a digital society which we need to take care about. And then especially from the IGF point of view, then governance, internet governance means very likely that taking care of those things, and then taking care of the users, taking care of the use of the AI for the society, etc. Therefore, a lot of scope is kind of extended because of that situation. So as I mentioned, then if we specifically identify the things, digital data is of course important for the artificial intelligence, and of course the web and the social network is going to be very important. But at the same time, a lot of IoT devices or robotics or sensors is going to be generating a lot of digital data in the other environment, right? In this room, probably how many IoT devices existing in this room? Probably more than 100, right? Because each of you have a smartphone and everything. And then the internet is a connection. The narrower definition of the internet is a TCP/IP connectivity, which is now not only through the mobile 4G, 3G, but mobile phone is a supercomputer now. But then also the Starlink and the satellite is covering the entire thing, and of course cable and the optical technology is very much being advanced. That's the internet part, network part. The computer and the computation is going to be, the NVIDIA, and then a lot of hardware generated from Taiwan is, kind of making this planet hot, right? running too much, and then taking care of a lot of data. That's a computation, but the GPU and everything for the AI is very much today's topic about the computation, what the computations are, but the high performance computing also solving a lot of things, and probably the cloud computing system is going to be the big change, and then quantum computer is coming, and it's really the big issue, especially for the security of the network, right? As a result, what we have is, achieved by the internet is a kind of the environment, the planetary mission, and the monitoring is going to be very important for this planet, which should be a responsibility of all of us around the world. And then the more individual one, then when you have a dream, then the dreams to be achieved. And you have idea, innovation, and then it can be achieved. And then so those are the very much kind of a personal creativity encouragement of the internet, right? So the internet environment is going to be very important, and for that reason. So what is the key concept? The leftover is a standard technology. So we share the standard. So think about the Netflix, right? Netflix, YouTube, Zoom, whatever. The video signal over our environment started from a standard called HTML5, which is basically the standard technology is going to accommodate and the built-in the encoding and the decoding of video transmission over the internet. So it's free. So I'm telling my students that somebody from a Netflix in this room? Okay, so I'm telling my students that the Netflix is a free rider of the internet, right? Because it's already the standard built in, and so they can just concentrating on a good programs, not for the transmit and then the receiver of the other side. So if you have a long-term internet users, then you remember that every time you need a kind of special media software, then you need to download onto your computer on the client side, and then getting a server to transmit the streams, right? It used to be, but not anymore. So it's a power of a standard. So the YouTube, Netflix, and the Zoom, or those are video players are concentrating on their business. So very much a low operation cost, low capex, the initial setting, but they can concentrate on the business, so which is good. So I'm telling also, to the students that the free riders, we are working for creating the free riders of the internet, right? So that's internet engineers' spirit. So anybody who's got the innovative idea, creative idea, dream, it all comes true by our technology and the environment. That's very much a power of the standard. When we have a standard, then they don't need to create their own specific proprietary things. That's a very much important concept. And the autonomously distributed system, this is a very much an important concept about the internet. So nobody owns the entire system. Nobody control is a central manner about the internet. And so that's autonomous distributed system is another concept. And then the global governance, which is here, IGF is maintaining all over the world multi-stakeholder model for the internet governance. So this is also the very important part of the, because it's all connected, right? We share the result, and then each of the components has a responsibility, its own responsibility autonomously, and then the global governance. So decisions going to be shared and discussed with a place like IGF. So that is a very much important thing. So why this global governance has been very difficult when we started ICANN, and then so ICANN time was very much when we started the ICANN, then it's like 3% of all the global population was using the internet. Now it's more than 70%. So this is a big change, right? So also, one of the great questions to the students was that, what's the difference between the international and the global space? So, international space is a very much like this is a IGF. Therefore, it's a UN-based community, but UN is a collection of the nation state, right? So that's an international space. So when we developed the internet, then it was not the international efforts, it's a global efforts. So therefore I call it kind of a new civilization on the planet, because it's no boundary of the nation state, because it started from the autonomously connecting the computers, and beyond the border even, what kind of a border, then we didn't care, because we are just connecting the universities and the research entity, and nobody cares. Nobody, policy people didn't understand, didn't care, didn't know about the internet. Therefore, the global space was automatically created in a sense, right? So we didn't care about the boundary at all. So, but then as a result, internet is the only human being asset, which is truly global. So anything on the internet is global. no boundary, no control by the government, and this is a very difficult thing. So today, this is very much merged together. So international space on the top and the global space over the internet, cyberspace, is now completely merged. So this is a very difficult part. So because from the international space, then we do have a kind of various different culture, currency, and yeah, this is very detailed, right? Are you still using the vertical writing? And then so because mainland China refused, stopped the official use of vertical writing, right?
Yep.
And are you still using it? I mean, vertical writing on a kanji.
We mix. We still
mix, right?
Yeah.
So as Japan. So when we worked on the World Wide Web vertical writing things, and I thought everybody was behind me and working together with me, and Taiwan, and then Korea, and then China, when we started that. But the leaving me one by one, and now the Taiwan is the only one. So so this is good. But anyway, so the different currency, different legal thing, different police, and so that's very much the world, international world. And then when we do something on cyberspace, then we need to use one of the paths to negotiate finance, and then there is economic meetings, and the police, then there is an Interpol meeting, and so culture, then the university should work, or culture department, and intellectual property. It's all based on a nation state based. But then we at the same time then we do have a global space, truly global space of the internet as well. Therefore, we are living now completely the hybrid society. So therefore, this is a truly new new civilization, I should say. Civilization, when I use a civilization always starting from the kind of stars and the physics and the mathematics and the science, and then creating a tool, and then creating a tool and creating a building. I understand that a lot of all the Japanese buildings still exist in this country. But anyway, so it's a construction and technology by tools, and then the society. So this is exactly the civilization. When the internet space is considered as a civilization, then starting from mathematics, calculation, computation, and we have computer chips from kind of this country, and then it's going to be a tool for the human being, and then we can achieve the Netflix and other things. So this is exactly the civilization, right? So let me face to the Asia Pacific. So as I mentioned, in the year 2000, 6% of the entire population. This size, by the way, it's going to be representing the population. But in that time, then Asia was almost Taiwan and Japan. But now it's growing very big. So this is one of the statistics number I used from the different sources. But the ITU recently announced very difficult. There is a green. Let me see. There is a green border in here, different greens. They decided, ITU decided to use CIS and Europe separatedly, but then Asia Pacific covers this area, and the Arab states, they separated the Arab states and Africa. So that's ITU data hub concept, but utilizing this one, then it's Asia Pacific is 66%. So we, from the internet inclusion. So the people without access to the internet, then we should work together. In that sense, we have kind of 30+% more to work together for the avoid stopping the internet inclusion. I mean, increasing the internet inclusion type of activity, which is to know. And Africa, we should work together to support them until remember the entire population-wise, then it's less than 30%. So to reach for the inclusion. So this is we do have a lot to work, right? Still, and so yeah, this is the same number. The world is about 70% for the utilizing the new ITU data, and then we have a largest number, by the way, of our population. Largest number of our population in this region means that collecting from the precise data, DNA data, and the bio data from the human being. If that is the power of artificial intelligence for the future, then the Asia Pacific is number one, right? Okay, so a lot to work. This is the same statistics. So another one that I talked about the standard, and then I created a little bit of a view about how the balance of a standard among the top one is North America, second one is Europe, and the third one is the Asia. This is for the ITF, which is, I think, relatively good, considering the history. But I think we should be, in Asia Pacific, we should be a little bit more of a participants of the contribution or the leading the standard of the ITF type of work, which is a protocol-based. And the next one is the World Wide Web Consortium, which is creating the standard of the HTML and the web-related standard, including ID, payment, and other things. Then so a lot of EPUB, Web of Things, payment, automotive as well, and then the video transmission as well. But now this is very, very more from the region. It's going to be expected, considering the size of the business, and so we should invite more to the standard thing, right? This is so the policy-wise. If when we are talking about the governance and the policy, then we do have a difficult time to now to explain what the architecture of the internet is. So I used the previous slide that I'm receiving a question like, we have a smartphone, then why we still need the internet? That is a question, right? So we have AI, then why do we still need the internet? And so that type of a question, right? So without understanding the architecture of the internet or digital technology, then that's a kind of a natural reaction. Then we have a smartphone. Do we still need a submarine cable for the internet because it's not connected anywhere, right? Okay, so this is a very natural question. But then actually we should talk to the policy people that what's a simple architecture and what we should work together to protect the internet, or think about the core internet, not the broader definition of the internet, which is how can we identify the core part of the internet versus a general understanding about the internet, which is another very important subject of this IGF. But so when we use a public core internet, and then so probably that's going to be a single internet and IP based, and the single one web is Tim Berners-Lee is talking about. The World Wide Web should be the standard thing to be shared around the world. So let's call it the public core internet. That was one of the discussions we did in Yokohama for the ITF. So let's each of the diplomatic occasion, then we try to put this concept to be shared with a diplomatic concept, and then so Japan is facing to EU, Asia, and America. Then so utilizing any opportunity that public core internet is very important for the digital data intelligence, and then the Quad and G7, and we just hosted G7 2 years ago. So we pushed the policy people to create a work of a digital ministers meeting that about the general availability and the integrity of the internet is going to be important. I mean, this type of announcement is going to be help for the any countries. We did that for the G20 and other opportunity that at least kind of try to encourage the policy people to understand the internet architecture, and then so, and also the submarine cable in the region is kind of changing a lot, very rapidly. So because of the a lot of cut is happening in this area, yeah, because of a lot of fishermen's boat is kind of from the policy reasons. Then they wanna appeal, they wanna demonstrate that this ocean is ours, right, type of a thing from the various countries, and then they are told to stay on a certain location of the ocean and anchored, and then so, but then it's a kind of critical sensitive ocean. Then they run away, and the anchor is going to cut the cable. So this is very much most of the reason why the cut is more than usual. I mean, usual means natural earthquake and other things. So in the region. So now we a lot of companies, especially now the submarine cable is installed by the will and the money of the GAFA type of players. So this is a very critical thing, and also the European wants to connect the Asia Pacific direct. This is a EU requirement now, and I'm discussing with the EU people for the direct optical fiber connection to us through the Arctic Ocean, which is a melted ice. Yep. And now they can install the cable. So this is very much a new area. So because of the ice melted, therefore the top yellow part is going to be important. From Asia Pacific, then probably it might be necessary to connect the South America part as well as the Africa part is going to be critical for the entire region. So I'm discussing about this type of cable installation around the world because from the kind of policy-wise, North Americas are controlled by largely by USA, right? And the EU is like identical. So it's we don't have a Asia Pacific United Association type of things. Therefore, probably the academics and the research and the educational community can form that kind of idea to work together for the very much arterial connectivity around the world for the internet, which is very basically the thing. So this is one of the examples that this is a Google web page, and they are now to support the entire South Pacific islands for the very much from a U.S. policy reasons, and then also Chile on the right, Chile in South America, and Australia, and the Guam on to Japan is going to be kind of they publicly announced that they're going to support the backbone of this region, and including the North America and the Vancouver. Vancouver is Canada, but the two U.S. So in connection, then we do have a new cable around the world for the basically the internet. So the research and the educational network can be the very important, can play the very important role. That's what the WIDE project started. How the WIDE project is started in '86 or something, and then still lasting even today. And then so splitting into the two groups, AIII is infrastructure, and the SOI Asia is educational. Institutional connection, which is still very active on the two areas. So we started from the very much technological challenges on an entire transponder to be controlled by the spectrum into the entire Southeast Asia countries except for Brunei, and for not any special reason. So connecting the other university campuses, and so look at this. This is a very important thing that entire countries, nation state, university are mutually connected by the mutual efforts with three entities. GIANT is a EU money, Internet 2 is a US money, and then we ourselves started to connect by ourselves among the countries. So at least our students, our next generation, our education can access the Internet almost freely, and sharing the wisdom. That's our next generation, which is very important to achieve. So that's one of the message that the research and the educational network community can be supported by the government, can be supported by the academics, and then some of the bigger group like APAN, Asia Pacific Advanced Network, or each of the nation state has its own. So most of the country has its own research and the educational network, and then the interconnection of the research and the educational network is going to be very important. So, and then why the reason I showed this spectrum allocation on the transponder of a satellite, which is standardized by the ITF a long time ago, which was very successful to start up the Asia Pacific Internet in a long time ago. But now we are challenging the very similar efforts today, utilizing the submarine cable, because when we are doing, look at this one. This is a technology called the ROADM technology. ROADM technology is a very much interesting is that the spectrum is going to be allocated by the operation, not the static fiber cable installation anymore. So there is a mechanism that you can add or delete the capacity to the branches of the optical fiber, which is new technology. And then I was thinking about, can we drop this into the ocean? And then so they did that. It's called the wet ROADM. Wet ROADM and the dry ROADM. Dry ROADM is for the data center, and the wet ROADM is for the optical fiber split. So utilizing this, and then I'm thinking about the red line is coming from Europe on the Arctic Ocean, and touching down the Tokyo, and then going to Taiwan, Philippines, and Singapore. Okay, so if we can do this by the ROADM technology, so it's all spectrum based communication from EU to Asia. So this can be done, and then this is a new technology. So we need to purchase the new cable and the equipment to design this one. So this is my design now, and I'm not talking to a Taiwan carrier or the universities yet. So this is the first time I'm talking about the new cable from Tokyo to Singapore is always dropping in Taiwan. Yep. So I know 3 of them. This is a very much confidential. This is open to the public. I'm sorry. But anyway, so this is interesting technology, and then it's I want the young engineers or even students learn how to play this operation, so that they're going to be the leaders in 5 years very soon, right? Okay, so there are other things. Let me think. When I stop the talking, okay.
You have time over there.
Oh,
You have 44 minutes.
44
minutes.
Oh, I can talk 44 minutes, including Q&A. All right. Then yeah, it's going to be some of my thoughts these days about this area of technology to share with you. Long time ago, when the MIT person approached me, and then started to discuss about the RFID, right? RFID is a chip without the battery to communicate, and ID, sending ID, and then I was involved. It started from MIT, and then the various universities around the world working together. Keio University was one of it, and then why just ID to share? So now it's assuming the internet, then you can access a database. If there is a unique ID, then you can access a database to retrieve what the product is. So it's basically a product code. But then each specific things, 2 bottles of milks, and then a different number. Barcode is the same product number for the 2 bottles of milk, right? So this is basically the RFID. So long time ago, when we started to discuss, a person called Kevin Ashton discussing with me, and Jun, this is like Internet of Things. Yeah. And so that's very much a beginning of the word IoT. But now T, and I was thinking that time, then it's not simply the ID, but the RFID itself is basically the computer, and receiving the signal and then making it as electric power, and then driving a CPU, and then accessing the ID and transmitting, utilizing that radio signal energy. So therefore, you don't need a battery on the IC card, right? So so now it's a lot of tiny and powerful batteries around, and then the full computer, full stack of protocol can be played. So IoT is now a computer, and then IoT is now RFID is a things, but the IoT device is now a full computer with a full protocol stack, full memory, and then it's now started to move with us or autonomously. So now it's becoming a robot rather than the things, right? So now when we are thinking about the internet space, then it's a human being and a robot is going to be a target of the thing. So RFID is now turned out to be a full stack of web and the TCP/IP, and so robot devices, IoT now. And then so drone, autonomous driving car, and PC, smartphone, TV, the home appliance, of course. So this is when it's already the IoT is has a big issue, right? So who owns this device, and so is that the vendor or owner, or so who owns the data? I mean, the web camera on the street capturing your face, and then so is that your data or the shop data, or whose data? And then it's a very much a rule-based thing. So it's a different in a country by country to utilize data. But now we need that kind of data governance in this area. And then also the security area is going to be very important. And if we can agree on who can access this data, and then so then how can we keep that limitation about access to the data? So this is a very much important things for the future. So basically the internet need to cover the security of the human, and they're supported by robotics, right? So that's a very much, the internet is for everyone was a catchphrase. And we discussed in the 95 for the INET time, but now it's internet is everyone and every robot right now. So this is a very much, so in order to cover the entire robots, then we do have new things for the infrastructure type, and then because the robot can be flying or moving anywhere, so the in Japan the how to count the internet coverage is a residence, human being, right? And then no mountain, no river, no ocean, no farms is considered as a coverage. So when the Japanese government, for example, say 100% coverage of the internet in Japan, then that means 100% of the people are connecting, 100% of the residents are connected, but not geographically 100%, which is about the 60% now in Japan. So this is the same for everywhere. And then from the surface of a terrestrial planet, and it's a very small. So I said 70% of the human population, but it's only not enough for the 30% of the geographical coverage of the surface of the planet. So, but then when we are talking about the flying object and the sensors and the other things, and it can be achieved almost technically by this low Earth orbit and the satellite and the other thing, but it's not still achieved. So, and also interesting is the drone is one, I don't know in this country, but in Japan, it's very, very difficult to deploy drone in a rural area as well, because it's considered when we apply the airplane law, then it's a very dangerous. I mean, it is dangerous, by the way. If dropped on top of your head, then you need a helmet all the way. I mean, therefore, there could be a kind of specific rules on it's called the drone highways, on virtual highways on the sky. And then make sure that the drone could be under control, which is only by the spectrum communication. Therefore, the 5G, I don't know in this country, and if you are coming from the mobile computing business, then I'm kind of hesitated to say that the fifth generation millimeter band, like a 28 gigahertz, is a very, very straightforward, a lot of broader signal. But it's very difficult to use. In Japan, it's only a Tokyo Station area by all the reflection of the building, and it works very nicely, but not in a suburb area. But then for the sky, it's go straight and without interfering and intercepting by the anything. So it might be affected. The millimeter band for the 5G can work. But anyway, so this is one of the examples that we need a drone. And also, what I want to specify is this part, 3D space. So the drone is flying on the area and over the sky. And then, so this height information is very weak for the existing map and height information. So, for example, when the wheelchair is moving around, then it's allowed in Japan only 2 centimeters of the steps. So the wheelchair is designed to go over 2 centimeters of step, but not bigger than that. So when we are creating the walking road, then you need to create a slope to accommodate the wheelchair, because under less than 2 centimeter thing in there. So this is one of the efforts, but then the baby car is very similar. And then Japan being a very much elderly society. So the elderly people just putting a cart for the shopping and anything, and then so we need to be very careful to design the road, and then so the navigation system can automatically detect that kind of a thing. And do we have a map? Like kind of a step height is more than 2 centimeter thing, and then navigating around that kind of difficult street. So these are one of the examples that we need a kind of three-dimensional sophisticated mapping anyway for the future. And the question is, how can we create that kind of a space? So in order to do that, then we can't depend on a GNSS, the GPS type of a satellite information, because GNSS, like a GPS, is the location is 50 meters of accuracy. Can be do the RTK and other reference point, utilizing a reference point, then it can be like a 5 centimeter or less. That's a current GPS technology. So we need the reference point, which is a terrestrial equipment, to be supported in order to achieve the centimeter level of accuracy. So, and then also during the war happening today, it's very much jamming the satellite signal for the location information and the timing information, by the way, provided by a GPS. But anyway, so this is very easy to intercept in the sky from the jamming signal. So this is a very critical infrastructure for the economy, but also critical for the security as well. And then height is nothing, right? I mean, if you have a highway and then a ground street, and your car navigation is going to be crazy, right? So in Tokyo, then if you are driving on a highway, and then it's a go straight highway, and then the car navigation system telling me turn right, and then I turn right, and then I'm going to drop from the highway, right? So this is happening. So this is amazing that kind of a common safety technology like driving automobile industry can provide such a dangerous instruction by the computer, right? So this is very, very strange. But this is because the satellite is too far to create the accuracy of the height. And so now, if you are familiar with your smartphone, then the smartphone has equipment of air pressure thing. So in a very much inaccurate height information can be retrieved from the air pressure type of information for the smartphone, but you still need a reference that we are on the third floor. Mm-hmm. So how many of your phone can, fourth floor, how many of your phone can tell your location is on a fourth floor? Very difficult. Sometimes it says second floor, sometimes it says fifth floor. So because the accuracy, as easy as 70 meter, and then so it's so now we started to discuss around the world about the 3 meter accuracy on 80% of the the statistic is now announced from FCC. This is the FCC United States, right? And then the EU also. And the FCC cares about the safetiness of firemen after 9/11 and the other thing. And then also the rescue point of view. Then especially in Japan, then we start, I think it started, the Nankai Trough earthquake. It's a, very much the big start, and then it's going to generate. We are expecting like a 20 meter of a tsunami wave and suffered around the coast of the West. And then if that is happening, then so if you are visiting Japan ocean-side, then you see the building, and then the big line on the the wall of a building that. run away beyond this line, and telling you. So this is a very, very common tsunami expecting area, unfortunately. But then, so you need to know that your family member is going to be which height your family member is going to be located immediately after the expectation of a tsunami, right? So in order to do that, then your phone doesn't work today. But the potential of air pressure and the communication facility is there. So there is a way. So this is what I'm proposing. Also the GPS backup is another issue. GPS is American Navy operation. Therefore, whatever is happening then in the history, then they kind of making a kind of intentionally operating in a wrong way. I mean, not stopping the services, frankly, right? So it's a general term is a PNT, positioning, navigation, and timing, which is a role of a GPS. And then, so accurate location is going to be necessary. And then synchronization of jitter is very important. So I'm running a root name server. Root name server is actually measuring that which latency of their services around the world, and they're putting a copy around the world. This is a role of a root name server. But then we need to synchronize the exact timing to be synchronized in order to receive the 1 point accessing this server, and then where's going to be the new location of the copy type of a thing. And also recently 8K video uncompressed, which is a 50 gigabps requirements for the transmission. And then it's very difficult for encoding and decoding latency of the video is different from encoding and decoding latency of a voice. So lip syncing is done in both sides. So a lot of TV 8K broadcasting equipment is utilizing a GPS in a receiving side and the transmitting side, and then synchronizing the lips and the images. So it's called a lip sync, which is also utilizing a GPS. So exact timing to be shared in the sending side and receiving side is going to be necessary. So this is called remote sync. And then when we are kind of advanced way of a digital twin type of a thing, in an emulation of the real world, in various purposes, then it's going to be very important for the accurate thing. And then so we are now challenging on a kind of a crossroad, detecting the human pedestrian traffic, and then so avoiding the traffic congestion or the traffic accident on the street. And then in order to do that, then it's very much a smart calculation and telling well, rather than the driver now, the automobile itself to stop, right? Type of things going to be necessary, right? And also, very favorite application from the finance industry is that they're going to do moving the money, and then the latency is going to be very critical for those industries. So those are the basically the requesters information. So in summary, it's very important that more accurate PNT things to be achieved, and it's not that difficult. So the atomic clock and the terrestrial PNT infrastructure, which is very important. Terrestrial PNT infrastructure is not that difficult anymore because we do have a smartphone ground station infrastructure already. So we have an additional GNSS, additional to GPS, the QZSS type of a thing happen to be, in operation from Japan to cover the entire Asia. But So how can we do that kind of reference point on the terrestrial, and then the calculation, and then the services? So this is a very much very easy way of providing the kind of QZSS satellite. So it's a 2 satellites model, but then we can now operating the 4 satellites on this tracking area, and then targeted on 7, and then the final target is 11. And if we achieve 11, then it's always 4 of them on the top of the quasi-zenith satellites, 4 of them, which is enough for the GPS equivalent. So even if GPS gone, then we do have our own. So this is very much the always 4, and the terrestrial infrastructure combination can achieve the very much accurate the location information as well. So the computation is going to be kind of existing computer to the quantum, which is very much important. And then what we have left is all the smartphone in this room connected, and then creating the supercomputer, parallel computer for AI, working together, which is not achieved yet. And then eventually, some way, some of the cryptocurrency system is now running on a smartphone inside the room, and then connecting each other. So which is very much a beginning. So it's, again, technically not impossible, but it's not achieved yet. And maybe we don't need that yet, but that is a potential. Another issue I'm raising to the Japanese government now is now don't rely on the internet infrastructure, digital infrastructure, computers, including computer and digital data. Our society is relying on those digital infrastructure, but those things can never work without the electricity. So electricity is very, very important. So I'm telling my government that the priority of the electricity to boosting up from the other critical infrastructure, that's what I'm telling and giving advice to our government. But the reason why is, I don't know in the Taiwan situation, I'm sorry, but Japan privatizing the electricity power things, and then breaking into 10 different companies. And each of the companies is good. Some of the companies are good. Some of the companies are not that good. And then it's not shared. So that was found actually in Ukraine before the Russia invasion. So they kind of recreating this 50 hertz, 60 hertz issue, and then the grid type of thing, Russian grid to a European grid, the transition was preparing just before the Russian invasion. So now this is a big issue in Japan. The Ukraine did that, and Japan cannot do that, and type of thing. So now we need the electricity. One of the things is that the data centers will be distributed around the, around the nation. Why? And then consuming the electricity locally, and doing the calculation and transmitting the result. Oh, okay, if there is an electricity power plant existing one location, and transmitting the electricity, then you need a very expensive infrastructure to pass the electricity, right, for a long distance. But if optical fiber, then it's a result of the calculation just transmitting to the long distance, which is very much different. So depend on the calculation, depend on the computation, but the electricity and the data location by design to do this type of local consumption of the electricity by the computers is going to be achievable. So especially the Tokyo-centric situation in Japan is causing most of the bad things about Japan. Right? So probably distributing the load of Tokyo to the nationwide is going to be very much important. So I kind of made up a strange concept, like when I was discussing with the electric companies, CEO, CTOs, then they especially talking about security things, and they always talking about the core grid. We are taking care of a core grid, the power plant and then the transmitting facilities. They are very expensive, okay? And those are core grid. And then so they started to be a more democratic way for the providing the electricity services called microgrid. But they still think that if something happened on a cybersecurity attack or something, then they shut down the core grid and the microgrid so that they can make a core grid safer. So I remember the hospital used to be not connecting to the internet, and therefore it's safe. But then all the attacking of the ransomware these days, attacking for the hospital because the hospital is easy to attack, right? Because the over protection and far behind from the internet space is very much increasing the danger situation, which is I see a very similar thing in electricity thing. But now we have a little bit more strange thing. I put the strange thing. My daughter is doing a training every night, and the bicycle type of things in the gym, and they're working 2 hours. All right, can we use this as electricity energy? All right, this is good for her beauty and her health and electricity as well. So this type of a thing, now the electric vehicle is now providing the VTH, vehicle to home thing. And when something happened to a home, then they can supply the electricity to home. And then each of the home had a solar panel, and which is now very critical, especially for the earthquakey country like Japan, right? So now, who's going to be optimizing the electricity? So can we only think about the core grid? Maybe not. And then working together with the microgrid and the optimization, that this is happening on the electricity, electric smart meter and the other thing now. You suffered with the typhoon in Tokyo, right? 2 days ago, 3 days ago. So announcement about the power failure on how many houses was announced every hour by national news broadcasting. That was explicitly the NHK News announcers said, this is from the power grid number. So now the electricity is now the smart meter. So they can collect that information immediately, real time. And how many houses power are down in real time. So very exact number they are now announcing. So this is microgrid already achieving. But I also need to have this type of very much unstable grid electricity use, including this type of battery type of thing. And I just temporarily named the stray grid, like a stray cat, right? And so probably we now can manage understanding all the situation and optimizing the society's electricity use. So probably very much a great optimization can be achieved with new technology, and then the clever use of things. When we understand every life, every needs for electricity, not only the huge data center, but also our life is now without electricity. It's very difficult to live now. So that's one part, and another part is AI. AI is probably you are very much familiar with AI now, and then so starting from a centralized calculation model, then the improving the model to be distributed, and the learning need accessing a lot of data, but inference can be distributed. Therefore, this is the idea I just told you about, the street corner AI processing for the avoiding the traffic accident type of things, and returning back to the automobile type of things needs a distributed AI type of things. And now it's a kind of a started, right? The Microsoft, the Copilot PCs very much, and then the Samsung's phone is now local AI inference, and then so started to work. So this is a very much the futuristic the data and AI type of computation. So now we need a very much important thing is that what kind of a data we can utilize. So I just started to work with a hospital for the utilizing the hospital data to be used for the researches, and of course for the patient, a doctor, and the health, national health, and other things, and which has been very much closed, and the privacy discussion was not there yet, and so the various public data, private data, open data is going to be kind of we should need the secure sharing and the secure use. Just okay, two more things, and then I'm gonna shut up. The space, well, especially the moon. The WIDE project recently started to work on connecting the moon, because it's getting very serious, and the private companies started to develop moon energy things. So energy plant experts is now flying to the moon. 4 tickets for the first arrival of this mission. 2 tickets is for Japanese astronauts, and it's not astronauts anymore. So they are just they are planning 200 people living on the moon, and then if 200 people living on the moon, moving around the rover, the automobile on the moon is running around and doing the energy plant built in on the moon. Now they need the internet, obviously. They need to communicate with this planet from the moon, and between, and they have a family, and then they're gonna communicate, and then unfortunately this side of a moon is not facing to the Earth. Therefore, we need the intermediate node to transfer. So this is going to be a very much a protocol definition for the end-to-end communication. And the Earth to the moon is a 2.6 second of a latency, which is very slow. Yep. But we experience that kind of a slowness, right? Mm-hmm. in the beginning of the internet. But so we tested. The WIDE project has a moon Wi-Fi station, and then inserting the 2.6 seconds of latency automatically. And then our researcher started to use connecting to the moon, and then started to communicate 2.6 millisecond, 2.6 second of latency. And most of the application from your PC say we are not connecting to the internet. so it's not, it's 30 years ago anymore. So our applications are not patient, like they were. And also the space agency wants to move, and Elon Musk as well, move to Mars, which is like, a lot far. So the DTN has been addressed in ITF since 2012, and now we are now revisiting the protocol and connecting all the equipment, which is one of the new mission. Another mission I'd like to mention is a medical inclusion thing. So medical inclusion is basically maybe this is the area of Japan-Taiwan, collaboration type of area, because the hardware and the factory automation robotics is now the left. This is a Toyota factory, and then this is a chip industry in here, and so all the very much a precise motion of the robotics is mainly generated from this part of the world, right? And so this is a Kawasaki heavy industry producing the medical surgery robot called Hinotori, which is Da Vinci-like, very much Da Vinci-like. But the characteristic is that the cockpit here and then the operation part is separated. This is a main difference from the Da Vinci. And then there is an expert medical doctor existing. So what we did between the Singapore and so we tested with a medical doctor that how much latency can you stand for doing the remote surgery thing, and then inserting the latency, and then found out that 100 milliseconds they can do the operation remotely. Then 100 milliseconds, we can go to the Hawaii and the back, and then cover entire Asia Pacific. So let's test with a Top Gun medical doctor and get them do the operation from Singapore to Tokyo. And so sending all the equipment to Singapore, and then sending the Top Gun medical doctor to Singapore, and then we did that, and successfully done in the last. This is a collaboration of the research and educational network in the region. So when I asked the medical doctor, what do you want more? And then the remote surgery, the scenario is like that. The Tokyo medical surgery thing, and the young doctor is taking care of, and the expert Top Gun medical doctor is located in Singapore. So very difficult part of the surgery, and then the young doctor shouted, then the professor, please help me. And then, okay, give me the control by Singapore, Top Gun doctor. And then 5 minutes of taking the control and doing the expert job remotely and giving the control back. Now you can take care of it, the rest of it. And then that was the scenario we did, and successfully done. Okay, then, I asked those medical doctors, and what do you want more? And then I need to be hearing other people's in the operation room, the voice and the location of the voice, sound. Then as if I was sitting in that room. So this is very much kind of virtual reality area. So it's very much a gaming technology can help. So this is again this part of the world can contribute. And so finally the internet civilization is very much kind of people is rely on digital technology now, and every single element of the society industry is going to be rely on the digital technology and the data. And then we do need a lot of discussion to set up a policy for introducing this type of a civilization in our space, but it's technically all possible. We need to have a kind of governance discussion intensively in order to achieve this work. So thank you very much.
Okay. Actually, Jun, you raised a very interesting question. It's really happening in Taiwan right now, and it's a big debate in the society. You know, Taiwan have two major things we are working on that. One is a semiconductor, because 65% of semiconductor is manufactured in Taiwan, particularly the advanced one. You know, the lower than 3 nanosecond. Lower than 3 nano, almost 93% is produced in Taiwan. But the people might be didn't thinking about that. Semiconductor costs a lot of electricity. They're using a lot of electricity. One TSMC, you know, the Taiwan Semiconductor Manufacturing, one single company, they consume 8% of the electricity for the whole island. Just one company, just one TSMC. So 8%, you know. And so recently, the electricity is keep pushing the government, say you need to think about, you know, for next 10 years, 20 years, because the electricity required is almost grow 10 to 20% up every year. There's one issue. And recently in Taiwan also have another issue. You know, there is an AI data center. You know, the computer company in Taipei or in this area. The Taipower is the only power company in Taiwan. And Taipower say we cannot provide that kind of electricity for the AI data center in northern part of Taiwan. The reason because most of the electricity is generated in the southern part of the Taiwan. They need to deliver, you know, the electricity from south to north. But you know, when you are traveling in the 100 kilometers, actually the power is a degree. And so that's the reason they told, well, if you want to have a data center, please, can you build in the south, not in the north? But the problem is the company, or particularly the politics, you know, the mayor of the northern part of the city, they say we are discriminated because we cannot have a data center in northern part of the Taiwan. We have to move to the south. So this is very interesting, you know, the Jun, you are just raising about that. And it already happened in Taiwan, you know, because as you know, TSMC already have a branch in, you know, in Kyushu. And TSMC tried to build a factory, manufacturing in Arizona, but not very successful.
Okay.
Because American culture is very different to Taiwanese culture or Japanese culture, because the American worker, they don't want to follow your rule. You know, they don't want to be monitored 24 hours. But you know, in the semiconductor company, you know, because if you miss 5 minutes, very possible a lot of weather will be waste. You know, so that is critical, and they measure every chip manufactured in U.S. will be 5 times costly in Taiwan, because the worker, because the cost, you know, and if you need a maintenance, you have to have a good supply chain around. So this is a lot of things, but TSMC do very successfully in Kyushu, because I think because Taiwan and Japan, the culture is much similar. You can tell the employees, say, always turn on your mobile phone on call even in the midnight, But you cannot do that for American, So this is you raise the issue, and I'm thinking about that. The same thing is really happening in Taiwan right now.
Yeah, that's a very important discussion. I mean, mostly what I was discussing in here, including those points, and then so I remember when I started to have a remote university class together, real time in the USA, and then Larry Rand-Weber and myself did a joint class of the same class in both universities, and that was a big article of the New York Times that time, and which was a very good beginning. But immediately, after the start of the one-term class sharing, and Larry need to have a breakfast and the donuts in all the students because it was too early to start the class. And I was buying a lot of sushi to my students to stay in the university campus. And then, so it's very difficult for the beyond the time zone. Yeah. And then that's the time I started to work and connecting all the universities in the region. So now the EU, Americas, and the Asia Pacific, one of the reasons is the time zone sharing of the more workable time zone sharing is achievable. Therefore, the connectivity in there and the real-time maintenance is going to be very important. Of course, culturally closer type of things are happening. And then electricity-wise, and yes, it's very much, the broader collaboration always creating the better solution. So think about the medical inclusion, medical connectivity. Think about all the medical doctors in the region can access all the patients in the region. And how many children's life could be, saved? Yeah, so even in Africa and the other location, that's probably the potential power of the internet civilization, I believe. And therefore, the optimization on the, say, medical doctor experts is also one. And the optimization of electricity and the location of a computation also one. And so who owns which one? And who controls the expert? And Taiwan controls the Kyushu semiconductor factory, or so this is very much a policy issue, and then once agreed, then technically that's feasible. Yep, so it's a very difficult. Another story that the semiconductor business happening on the moon, then that's a different thing. But now we can always approaching from the infrastructural technology and the operation first, and then creating the solution to the policy people. That can be achieved, I believe.
I'm sorry, I ran out of the time. We don't have another time for any question. So let's give the Jun Murai a big applause, and thank you very much for his talk.
Thank you very much.